Suppose we have w, x, y, and z satisfying these first three equations. So what is the value of this fourth expression? Now, our first thought should not be to solve w, x, y, and z individually. We cannot do that. We only have three equations up here, but four unknowns, so that won't get us anywhere. So, what can we do? Well, we gotta notice a pattern within the equations. Well, notice that here we have 1 minus x, and this is 1 minus z. And this over here is 2 minus x and 2 minus z. And the next one is 3 minus x and 3 minus z. So we see that there's a pattern in the equations. It goes 1, 2, and 3. It's inside the brackets as well, right? So, knowing that, we can actually construct a more general form of each of these expressions. We'll let the function f of k be equal to w times k minus x squared plus y times k minus z squared. Alright? So we see that when k is equal to 1, we get this first equation. When k is equal to 2, we get the second equation. And when k is equal to 3, it's this third equation. So our question is basically translated to, what is f of 4? Given that we know what is f1, f of 2, and f of 3. Here's the thing. Whenever you see a complicated problem, always try to retranslate it into something that is more manageable. Okay, so now that we've translated it into this form, let's get our answer. The thing is how? How do we get f of 4? Okay, sure, we know f of 1, 2, and 3, but what do we do? Well, let's consider expanding these brackets. If we expand this, well, that's a binomial squared. So by the binomial squared formula, this is w times k squared minus 2kx, and then plus x squared, right? And for this one, we have y times, we expand this, k squared minus 2kz, and then plus z squared. And that is the expanded version of our binomial squared. Now let's distribute the w's and y's in. So if we distribute the w in here, we get wk squared minus 2wkx plus wx squared, right? And if we distribute the y in, well, here we would get yk squared and then minus 2ykz, and we have plus yz squared. And that is our expanded version, truly expanded. Now, before we go ahead and collect like terms, like we're not going to instantly go ahead and collect like terms and start factoring. Instead, notice that without even doing any more simplification, we can see that this expression, though complicated, is basically just a quadratic expression in terms of k. So notice we have k squares here, right? And we also have regular k terms, so k to the 1 terms. And we have constant terms, like these two. If we treat w, x, y, and z, or z, as constants, we have a quadratic expression in terms of k. So basically, we can write this as a general form of a quadratic expression. Let's write this as ak squared plus bk plus c. And now we have this is still equal to f of k. Notice how that greatly simplified our expression. We obtained a simple quadratic from all this mess. Now, to get f of 4, we just need to plug in 4 for k. However, we don't know what a, b, and c are. If we knew what they were, we could get f of 4 no problem. We could get them, however, because we know what f of 1, 2, and 3 are, right? So, let's plug in k to be 1 here. This would get us a plus b plus c. The k's are just 1s. So, you get a plus b plus c. And at the same time, f of 1 is equal to 2. So there we go. We can also plug in k to be 2. That would get us 4a plus 2b and then plus c. And f of 2 is equal to 3. Moreover, we have, if we plug in k to be 3, we get 9a and then plus 3b plus c is equal to 6. And there we go. We have 3 unknowns, 3 equations. this should be enough. Let's name the equations. We'll call this equation 1, equation 2, and equation 3, right? And we'll get to solving A, B, and C. We can do equation 1 minus equation 2. This over here would get us A minus 4A, that's negative 3A. And then B minus 2B, that's just negative B. The C's cancel out. And here we have negative 1. This is still not enough though, so we need another equation. Thankfully, we can do equation 2 minus equation 3. Well, we would get this, which is negative 5A, and this, which would be negative B. The C's again cancel out, and 3 minus 6 is just negative 3. Perfect. Now we have two separate equations. These two equations only have two variables. We can solve. Let's add these two, let's subtract these two equations. This way, negative B plus B cancels out, right? And we have negative 3A plus 5A, that's just 2A. And negative 1 plus 3, that's 2. So A is equal to 1. We already got one variable. We can then plug in A back into like this equation, right? Then negative 3 times A, that's just negative 3, minus B is equal to negative 1. We can solve. B is equal to negative 2. We got another variable. So let's box that in. Finally, we know what A is, we know what B is, we can get C. If we plug them in, A is 1 and B is negative 2. Here we have plus C, this is equal to 2. Now, you can solve this. If you were to actually solve this, you would get C is equal to 3. And now we got all three variables, A, B, and C. Let's go ahead and plug this in. F of k is just equal to k squared minus 2k, and then plus c, which is going to be plus 3. And that's our quadratic. Now, there's absolutely nothing stopping me from just plugging in k to be 4. If we plug in k to be 4, we get f of 4 is equal to 16 minus 8 plus 3. One can evaluate this to be 11. And that is the answer. We got f of 4. So this question mark over here is 11. If you found this interesting, then please do consider subscribing. Thank you very much. See you later.